garage door was energized because the neutral and ground wires were improperly connected at an upstream outlet. This created a scenario where the ground wire became energized, posing a potential electrical shock hazard. The root cause was traced back to incorrect wiring in an outlet. Specifically, the hot wire was connected to both sides of the outlet, rendering it non-functional. This miswiring also resulted in the downstream neutral wire becoming energized. The hot and neutral wires of the downstream outlet were swapped, establishing a path for electricity to flow, which allowed some devices to operate. The exact configuration of the ground and neutral connections that prevented the circuit breaker from tripping is unclear, but the ground wire was energized due to this improper connection. The solution involved correcting the wiring at the initial outlet. This included disconnecting the improperly connected neutral and ground wires and ensuring the system was properly grounded according to electrical codes. Properly grounding electrical systems is crucial for safety. When an appliance or electrical device has a fault, the ground wire provides a low impedance path for fault current to flow back to the source. This high current flow causes the circuit breaker to trip, quickly interrupting the power and preventing electrical shock. Without a proper ground, a fault can cause metal parts of the appliance or device to become energized, creating a dangerous shock hazard. In a properly grounded system, the ground wire is connected to the grounding electrode conductor, which in turn is connected to a grounding electrode, such as a ground rod or a metal water pipe that is in direct contact with the earth for 10 feet or more. This provides a direct connection to the earth, ensuring that any fault current has a low impedance path to flow back to the source. The neutral wire, on the other hand, is the return path for normal current flow in a circuit. It is typically connected to ground at the service entrance, but it should not be connected to ground at any other point in the wiring system. Connecting the neutral and ground wires at multiple points can create a parallel path for current flow, which can cause ground loops, increase neutral currents, and potentially energize ground wires. In this particular case, the connection between the neutral and ground wires at the first outlet allowed current to flow through the ground wire, energizing the garage door and creating a shock hazard. Correcting the wiring at the outlet involved disconnecting the neutral and ground wires and ensuring that the ground wire was properly connected to the grounding electrode conductor. It's crucial to use a multimeter to verify that the ground wire is properly grounded and that there is no voltage present between the ground wire and a known good ground. In addition to correcting the wiring, it's also important to inspect the entire electrical system for any other potential wiring errors. This includes checking all outlets, switches, and junction boxes to ensure that the wiring is properly connected and that there are no loose connections or damaged wires. It is also crucial to ensure that all circuit breakers are properly sized for the circuits they protect. Overloaded circuits can cause circuit breakers to trip frequently, which can be a nuisance, but they can also be a sign of a more serious problem. Over time, repeated overloading can damage the wiring and create a fire hazard. To avoid overloading circuits, it's important to know the amperage rating of each circuit breaker and to avoid plugging in too many appliances or devices into a single circuit. Extension cords should only be used temporarily and should never be used as a permanent wiring solution. The National Electrical Code, or NEC, provides detailed guidelines for electrical wiring and grounding. It is essential to follow the NEC guidelines to ensure that electrical systems are safe and reliable. The NEC is updated every 3 years, so it's important to stay up to date on the latest requirements. Some key NEC requirements related to grounding include the following. NEC Section 250.4. A5 requires that the grounding electrode conductor be connected to a grounded electrode that is present at the building or structure being supplied. Common grounding electrodes include ground rods, metal water pipes that are in direct contact with the earth for 10 feet or more, and concrete encased electrodes. NEC Section 250.24. C requires that the neutral conductor be grounded at the service entrance. This is typically done by connecting the neutral conductor to the grounding electrode conductor. NEC Section 250.142. B prohibits the use of the neutral conductor as a grounding conductor for equipment grounding purposes. This means that the ground wire must be run separately from the neutral wire. NEC Section 406.4 D requires that all receptacles be grounded. This means that the receptacle must have a grounding contact that is connected to the equipment grounding conductor. In addition to following the NEC guidelines, it's also important to use high-quality electrical component. This includes using properly rated wire, circuit breakers, and receptacles. Using substandard components can increase the risk of electrical shock and fire. When working on electrical systems, it's essential to follow safe work practices. This includes turning off the power at the circuit breaker before working on any electrical wiring. It's also important to use insulated tools and to wear appropriate personal protective equipment, such as rubber gloves and safety glasses. If you're not comfortable working on electrical systems, it's best to hire a qualified electrician. Electrical work can be dangerous, and it's important to have the knowledge and skills necessary to do the work safely. Always remember to double-check the wiring before turning the power back on. Use a multimeter to verify that the voltage is correct and that there are no shorts or ground faults. By following these guidelines, you can help ensure that your electrical system is safe and reliable. Furthermore, improper wiring configurations can lead to other issues. For example, an open neutral condition can cause appliances to experience overvoltage, which can damage sensitive electronic equipment. An open neutral can occur when the neutral wire is broken or disconnected, which can cause the voltage to rise on one leg of a split-phase 120 volts to 140 volts system while dropping on the other. This can be especially problematic for devices that are designed to operate at a specific voltage. Regular inspections of electrical systems can help identify potential problems before they become serious. These inspections should be performed by a qualified electrician and should include checking for loose connections, damaged wires, and other signs of wear and tear. It is also a good idea to have your electrical system inspected if you are buying or selling a home. A home inspection can identify any potential electrical problems that need to be addressed before the sale is finalized. Additionally, consider installing arc fault circuit interrupters, known as SIs, in your electrical panel. SIs are designed to detect arc faults, which are a common cause of electrical fires. Arc faults can occur when there is a break in the insulation of a wire, which can cause a spark to jump to a nearby grounded object. SIs are more sensitive than standard circuit breakers and can trip much faster, which can help prevent electrical fires. It is also important to keep electrical panels and outlets free from obstructions. Do not block access to electrical panels with furniture or other items. This can make it difficult to turn off the power in an emergency. Also, do not overload outlets with too many extension cords or power strips. This can create a fire hazard. Proper maintenance of electrical systems is essential for safety and reliability. By following the guidelines outlined above, you can help ensure that your electrical system is safe and functioning properly. Regular maintenance and inspections can help identify potential problems before they become serious, which can save you time, money, and potentially prevent a dangerous situation. Another important consideration is the use of surge protection devices. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges. Voltage surges can be caused by lightning strikes, power outages, or other electrical events. SPD work by diverting the excess voltage to ground, which prevents it from damaging sensitive electronic equipment. There are two main types of SPD: whole house surge protectors and point-of-view surge protectors. Whole house surge protectors are installed at the electrical panel and protect all of the electrical equipment in the house. Point-of-view surge protectors are plugged into individual outlets and protect the equipment that is plugged into that outlet. It is recommended to use both whole house and point-of-view surge protectors to provide comprehensive surge protection. When selecting SPD, it is important to choose devices that are properly rated for the electrical system. The surge current rating of the SPD should be high enough to handle the expected surge currents in the area. It is also important to choose SPD that are UL listed. UL listing indicates that the SPD has been tested and certified to meet safety standards. In addition to surge protection, it is also important to protect electrical equipment from power outages. Power outages can damage sensitive electronic equipment, especially computers and other devices with digital components. Uninterruptible power supplies, or UPSs, are designed to provide backup power in the event of a power outage. UPS typically use batteries to provide power for a limited amount of time, which allows you to safely shut down your equipment without losing any data. When selecting a UPS, it is important to choose a device that is properly sized for the equipment that it will be powering. The volt amps, or VAR, rating of the UPS should be high enough to handle the load of the equipment. It is also important to choose a UPS that has the appropriate output voltage and frequency. Additionally, consider using tamper-resistant receptacles, known as TRR, especially in homes with young children. TRR have internal shutters that prevent foreign objects from being inserted into the receptacle. This can help prevent electrical shocks and burns. TRR are required by the NEC in new construction and renovations. They are a simple and inexpensive way to improve electrical safety in your home. Furthermore, always ensure that electrical work is performed by a qualified and licensed electrician. Attempting to perform electrical work without the proper training and experience can be dangerous and can lead to serious injury or even death. A licensed electrician has the knowledge and skills necessary to perform electrical work safely and in accordance with the NEC. Before hiring an electrician, be sure to check their credentials and references. Ask for proof of insurance and licensing. A reputable electrician will be happy to provide this information. It is also a good idea to get multiple bids before hiring an electrician. This will help you ensure that you are getting a fair price for the work. When hiring an electrician, be sure to get a written contract that outlines the scope of the work, the materials to be used, and the price. The contract should also include a timeline for the completion of the work. Read the contract carefully before signing it and make sure that you understand all of the terms and conditions. Finally, remember that electrical safety is an ongoing process. It is not something that you can simply do once and then forget about. Regularly inspect your electrical system and take steps to address any potential problems. By being proactive about electrical safety, you can help protect yourself, your family, and your property from the dangers of electricity. If you have any concerns about your electrical system, do not hesitate to contact a qualified electrician. They can provide you with expert advice and assistance. In summary, this scenario underscores the critical importance of correct electrical wiring and proper grounding. The interconnected neutral and ground wires created a dangerous situation, highlighting the need for adherence to electrical codes and safe practices. Regular inspections and maintenance by qualified electricians are crucial for maintaining safe electrical systems. Always prioritize safety when dealing with electricity.